This is we are talking about throughput when we know the latency between two endpoints. Very simple. Let's say point A and point B has a latency of 16 millisecond. We always get round trip delay or round trip time. Actually, it is two-way delay. So 8 millisecond in going and 8 millisecond in coming back for that packet. So we are talking about TCP here, and we are dividing 1000 millisecond by 16 millisecond. So we get kind of 62 window. So what we are saying is we can send 62 window. Why we took 16? Because we need to consider acknowledgement coming back. An acknowledgement packet again will take same latency of 8 millisecond from point B to point A. So we said 62 times, or 62 times we can send the window, but what is the data we can send? But what is the window size? We took here just an example of 65,000 byte, which is half megabyte. So 62 window of half meg each, we ideally, theoretically, we should be getting 30 megabit per second of throughput on that circuit, which not always the case. Reason, because window size will be keep on decrease or increase. Actually that will decrease or latency will be impacted, because ideally scenario we are talking about here, but practically A and B may not have that resource. This is legacy maximum window size of half megabit. Now we took another example with same latency between point A and B, but now we change the window size from 65,000 to one third of that. Let's say 65,000, 22.5 kilobyte, which we saw in Linux box. So this is 196 kilobit, let's say one fifth of a megabit. So we are talking again 62 window by 1.5. We are getting 12, approximately 12 megabit per second of the throughput. Now in third scenario, we reduce the latency, and what we did is, when we divide how many window we can send, 1000 divided by 10, we got 100 windows of, let's say, half megabit, one that maximum window size legacy setup. Then we get 50 megabit per second of throughput. These are example I'm putting myself to clear on that math, which is should have straightforward way back, but it's not. It was not that time. Now I took another example of 60 millisecond of throughput with, let's say, what we talk about is 16 window. Now I took latest example of window scaling factor and scale by 2. So we are talking about maximum window size of legacy 65,000 byte half meg into 2, that means 1 meg. So if we are getting 16 window by 1, so what we are getting is 16 megabit of throughput. Now fifth example, I reduce the latency. Not only latency, I took window size of 1 megabit, which is double than legacy of half megabit. So we should be straight away getting 66 megabit per second of throughput. Now there are two factors need to be considered when we talk about throughput between point A and B. Latency has to be low, window size has to be maximum. I know there are some discussion around MTU and MSS, but if we talk about MTU, so that's really does not matter. We know in Ethernet we have 1500 bytes, and when we have tunnels and other scenario, it goes to 1300 bytes because of overhead of IPsec and other security protocols, but that reduced just 10%. So from application perspective, from MTU and MSS, it really doesn't matter more than 10 to 12%. But what killing factor for throughput between point A and point B are latency and window size. So window size has to be way bigger and latency has to be way low. Maximum window size December 2018 I have seen so far is either 1 gig or 8 gig, probably 1 gig. So 1 gig of window size and latency of, let's say, 1 millisecond on a LAN. Assume how much throughput we're gonna have. It's gonna be a lot, really a lot.